Let's see if we can find the area enclosed by the curves f of x equals 2x minus 3 and g of x equals minus x squared plus 4x. But it doesn't tell us what x values to stay between. How are we going to deal with that? Well, let's graph these functions and take a look. We have to graph them anyway to know which curve is on top. For f of x equals 2x minus 3, that's a straight line with y-intercept negative 3. So it's going to be going through negative 3 on the y-axis. And then it's got a slope of 2. So the rise over run will be 2 over 1. So I'll go up 2 for every 1 I go over. Okay, so there is our f of x. G of x is a parabola. It's going to be upside down because of the negative coefficient on the x squared term. The vertex, well, the x-coordinate is at minus b over 2a. So that's minus. B is the coefficient on the x, which is a 4. And a is negative 1, so the x-coordinate of the vertex is 2. To get the y-coordinate, we just plug that in to the function formula. So I'm going to have minus 2 squared plus 4 times 2, which is negative 4 plus 8, which is 4. So the vertex is at the point 2, 4. There. And it's going to be an upside down U because it's opening downwards, we said. Let's see where it crosses the x-axis. So for x-intercepts, we put in y equals 0 and solve minus x squared plus 4x equals 0. If we factor out a negative x, we have negative x times the quantity x minus 4 equals 0. So either negative x equals 0 or x minus 4 equals 0. In other words, x equals 0 or 4. So those are the coordinates of our x-intercepts. And we draw an upside down parabola through those points. Now, if you look at our two graphs, there is a region that is completely enclosed by those two curves. And it's that region right there. That is the region whose area they're asking us for. That's what they mean when they say find the area enclosed by the curves. Now, the thing is, we have to figure out where the left endpoint and the right endpoint are. So we need to integrate from there to there. Now that right-hand endpoint, it looks like a 3, but we can't tell from a rough graph like this, and we have no idea what that left endpoint is. The way to find where two curves intersect and let me state this generally to help you in the future, the intersection of two curves f of x and g of x is going to happen where f of x equals g of x, where they have the same y values. So we set 2x minus 3 equal to minus x squared plus 4x and solve for x. So let's see, let's add x squared to both sides. And let's subtract 4x from both sides. That gives us x squared minus 2x minus 3 equals 0. We can factor that. That factors as x minus 3 times x plus 1. And so we get x equals either 3 or negative 1. So I actually feel kind of proud that my graph actually looked like that intersection on the right was at 3. And the intersection over on the left we've just determined is at negative 1. So now we can find that area. The area will be the definite integral from negative 1 to 3 of the curve on top, which is which one? That's the parabola. So that's minus x squared plus 4x. Then minus the curve on the bottom, which was, what was that? 2x minus 3. Let's simplify our integrand. So integral of negative 1 to 3 of negative x squared plus 4x minus 2x plus 3 dx. And we can combine like terms to get minus 1 to 3. And then we have minus x squared plus 2x plus 3 dx. So our antiderivatives are minus 1/3 x cubed plus 2 times 1/2 x squared plus 3x, going from negative 1 to 3. We can cancel the 2's in that middle term and have just an x squared. So now let's plug in our limits of integration. We have minus 1/3 times 3 cubed plus 3 squared plus 3 times 3 minus what we get putting in the negative 1. So putting in the negative 1, we have minus 1/3 times negative 1 cubed plus negative 1 squared plus 3 times negative 1. Then back to the front end of the list. At the first term, we can cancel 3's. That'll leave us just 9. Negative 9. And then we have plus 9, because 3 squared is 9. Plus another 9. Minus, and in the parentheses, let's see, we have a negative 1 times negative 1/3, that's a positive 1/3. Then negative 1 squared is positive 1, and then we have minus 3. The 2 9's on the front end cancel, leaving us just a 9 outside the parentheses. And then inside the parentheses, 1 minus 3 is negative 2. I guess at this point, let's distribute the minus into the parentheses. You could combine the terms in the parentheses if you'd rather do that. It doesn't matter. But I'll do it this way. And so at this point, we'll have 9 minus 1/3 plus 2. 9 plus 2 is 11. And 11 minus 1/3 is 10 2/3. Or, if you prefer, 32/3. So that is our area for this region.